All right, hey folks, I am Tyler Moody. I work as a platform engineer at Sonic, and I'm here to talk to you guys about Vault and Consul, running a highly available secrets management store. So yeah, that's pretty much it. Let's kick this off. What am I looking for here? All right, so I got 4 goals in this talk. 1, talk through Vault, the basics of Vault, so you guys understand kind of how it works, bare minimum. Same with Consul. Consul is significantly bigger as a product than Vault, so there will be a focus on how Consul plays into Vault and working as a backend. Some useful automation tips, because Vault is finicky sometimes in the sense of it's meant to be really secure, and so you need to plan for that when you're trying to automate or build highly resilient clusters with it. And then a sweet demo. So fingers crossed that the demo works. Last I checked at like 2, 3 in the morning, it was running, so we'll see what happens. So Vault functionality. Before we even dive into it, really, you need to think about HashiCorp has a specific ideology in mind with Vault. So they have this security threat modeling, and the goal is secrets are secrets for a reason, and they need to be safe. So you need protection at rest and in transit if you so choose to turn that on. You need accountability if anybody's accessing those secrets. And you need high availability because those secrets are important. And if you're rotating them or doing any work with them, you need to make sure that you can get to them. So there's a whole page with it, and it's got a little more. So we're going to go look at that real quick because I'm sure I missed something. There's many bullet points on it. But so their threat model is basically preventing any sort of eavesdropping, tampering with access that was not logged, like audit logs or anything like that, or just not allowed. They do not protect against manipulation of the storage backend directly. So whatever you're using to store your stuff, because Vault handles the encryption and it handles kind of the access to it and the accountability for that. But whatever you're using to store it in, you need to make sure it's locked down, because if someone gets access to that system directly, they can technically pull encrypted values out. They still got to break the encryption. So it's not as big of a deal as it could be, but it's not pleasant either. I would not recommend it. So, sealing. Vault has a default functionality of sealing itself. When Vault comes up, when you initialize it for the first time, it comes up sealed. And what that means is it is inaccessible until you go through and you initialize it and then you unseal it using a quorum of keys. It's not going to be able to do anything for you. And you can always seal it again. So if you determine that someone has access to your Vault that you don't want having access to, and you don't have time to go figure out where that's coming from and like cut that traffic off at the knees, seal Vault. Now, your applications won't be able to reach out, so you need to make sure that they're resilient and be able to keep running without like directly accessing secrets repeatedly, or there isn't an upcoming rotation, but keeps you safe. Vault also offers credential and secret leasing. So one of the best examples I can think of for this is database credential leasing. So you can actually hook Vault into RDS and provision credentials on the fly for your applications, and then set those up to auto-rotate. So at some point, your application is going to realize, my credentials are no longer valid, reach back out to Vault, get new ones. And you can actually set auto-renewal on for that as well, which there's not even that issue of once it's invalidated, it's all built into the flow of, okay, I need to go retrieve some more credentials and keep going. And then extremely granular access control. So this is another one that I have a link to, because they've got all kinds of basically recommendations around this, but everything is based around the policy. Vault operates under the hood as a file system. That's how you access. So you're always giving a path to a secret you're going to read, or a credential you're going to lease, or whatever else you're trying to do. So you can lock down via policies access to specific paths and the ability to take action against them. Read, write, there's multiple others. Let's see, read, write, lease, and then also sudo. So they talk about Vault policies, and basically the idea is you get a connection to an authentication backend and you're mapping these policies to those users. There's no SAML right now, but they have LDAP's like the go-to example for it. And this allows you to take those policies and apply them to users or apply them to groups, and put those users in a group, and basically limit access within Vault even once they're logged into the specific things you're storing in there. And it makes it really easy to manage and operate. There's still an operational cost because you're still having to update those users as you go. And if a new team spins up, they need a new space, or they need access to a previously created API and its secrets. I mean, there's still going to be some ops cost to that, because that also does not lend itself super well to automation. But they've tried to make it as granular and as simple as possible. They're definitely balancing between those. Let's see, back in. So, more. All right, so secrets. Vault's main goal is long-term storage of valuable secrets at rest. Keep them encrypted, keep them safe, keep them centralized, make it easy to swap them out, but keep them safe, first and foremost. They have a number of ways you can do credential leasing, which was what I was talking about earlier. So you've got database, you've got cloud providers, so you can basically lease an IAM role from AWS, for example. I don't know what the Google or Azure equivalents are, but get limited access in on a time-based credential to perform actions against AWS, spin up EC2s or RDSs, whatever you need to do. App role, which is your main focus for applications reaching out to secrets. The way that works is you have an access key and a secret access key. You have an app role ID and a secret access key. Those are used to retrieve a token. Then the token can be used to actually retrieve the secrets. So it's a multi-step process, super secure. And really all that you need to make sure that it's really safe is that your secret key is short-lived for the application and is consistently rotating. That way the tokens are invalidated frequently and secrets are not easily retrieved with older credentials. And then the last one is transit. So transit is actually something you have to enable, but it does allow encryption in transit for your values past like what just having a certificate would do. It's not something that I have a lot of experience with, but I wanted to include it because that's one of the really like valuable pieces with vaults and why a lot of people are leaning towards it. So these secrets are all secret engines that you can enable, and there's a bunch more, so we're going back again because it is a huge list. So this is all the secret engines that you can use. There's a pile. Some of them are KV, some of them are for credential leasing. So like AWS is specifically for credential leasing as opposed to secret store. But then with databases, you've got a whole pile of databases, which includes things that you could provision via RDS, and that would be like a secret store. The big thing about this when you're going to pick a secrets engine is make sure that if you're trying to build this resilient, and I'll show this in the demo, if you're going to try to build something that's resilient, there are only certain secret engines and backends that lend themselves well to highly available systems, and they're documented pretty clearly in the Vault docs, but it's something to be aware of because otherwise you're going to own a lot of that and it's not super easy to build. Like HashiCorp's trying to give it to you for free, so take advantage of that and use some of the things that they recommend. All right, so backends. It's the location of the storage. This is what I was talking about. So you get your backends, RDS backing. You can use a file system backing. We're using Consul in the demo, so Consul operates as a KV store, and it's a distributed cluster, so it's just KVs everywhere. And Vault handles the encryption and storage into that Consul cluster, but Consul's the one that maintains it. So again, when it comes to resiliency, you need to be concerned about your Consul cluster because that's the storage. If Vault goes down, it sucks, but you can always spin up another Vault server, back it to Consul, and you've got access again. If your Consul cluster goes down, you're in a world of pain and you need to figure out how to restore that or all your secrets are gone. And then the other pieces that are really important to know for the high availability resiliency pieces are auto unseal and then the request forwarding versus read replicas. So I was talking about earlier, Vault comes up sealed. That's a given. But what you can do is you can leverage a tool like AWS KMS is a really good example. That's the one we're doing in the demo. You can configure a KMS key and configure the Vault instances to reach out to that KMS key, and it will unseal itself on the initialization. So you no longer have a quorum of init keys that you have to go and put through the Vault instance itself. Instead, it goes, I can see KMS, I can prove this is mine. Cool, I'm unsealing. And this is really important for when you're running like a large cluster, or if you have a Vault instance go down. If you have it in an auto-scaling group or something like that, and it's going to spin back up, it'll come up and unseal itself because it's going to back to that console cluster, and then it's going to reach out for the KMS key and go, sweet. I've got a valid config on the back, I've got all my secrets, and I can reach out to KMS and unseal myself. The other thing with the request forwarding versus read replicas, so if you don't get Vault Enterprise, you get request forwarding as opposed to read replicas. So what that means is if you're running 3 Vault instances, only one of them is live and considered the cluster leader. The other 2 just forward traffic along to the live one. If the leader goes down, the cluster goes back, has a leadership vote, figures out who's the new leader, and that's the one that will service traffic. So in the demo, I have a load balancer that's routing traffic to all 3, but really what's happening is if it gets routed to a non-leader, that traffic gets forwarded back to the leader directly from the Vault instance that it reached out to. Yeah. So on to Consul. A lot of information, I know. The demo will, I think, clear some of this up, hopefully, but lots of stuff. Consul, first and foremost, is service mesh. That's its job. It's got a bunch of other really cool things that come with the service mesh, but HashiCorp figured out that, hey, this is already a highly available distributed cluster with KV store, so why don't we use it for a backend, and then we can make all the DR stuff built in if you hook it. So that's why a lot of people use the Consul backend. But yeah, operates as a service mesh, KV store, does health checks against your applications if you're registering your applications and leveraging it as a service mesh, and it does that for Vault too. So Vault, it's doing that under the hood. You don't have to worry about any of that, but when you back to a high availability storage and you specify Consul, a lot of this stuff's going on under the hood, which is really handy. So it uses Surf, which is another HashiCorp product, and it's like their base product, and it's the actual distributed cluster piece. Handles the leader election for a distributed cluster, and it does WAN versus LAN communication. So, let's see, I have this written. LAN is your private pool in a data center. So if you're running at a US East 1 and you've got a bunch of Consul servers in there, those guys are communicating on LAN. Technically, they have also reached out over WAN, but that is not their chief traffic going through. It's all going through LAN. Now, if you're going cross data centers, so you're going US East and US West, your Consul servers between those are going to use WAN communication, and they're actually going to talk through that. And that's why it communicates across a half dozen ports, TCP versus UDP and LAN versus WAN. I think those make up at least 2, if not 4 of the ports that need to be open on a Consul box to work. And then Consul runs as either a server or an agent. It's a little confusing because when you execute Consul, you execute it as an agent, like it's Consul agent start, but it operates as a server, which your server is going to be your KV store, that's going to be your service mesh, that's your single source of truth across a distributed cluster. The agent is what actually facilitates communication against other applications. So that an application can reach out to the agent and go, I need this key value pair, and it's the agent's responsibility to go back to the servers, retrieve it, and then serve that up to the app. And that's what's happening with Vault. So with Vault, it's actually talking to a Consul agent, which then goes all the way back out to the server and says, I need my config, I need this secret or whatever. And the Consul server serves that back up to the agent. Agent gives it to Vault, Vault decrypts it. You've got an unencrypted secret. Here's the list of Consul ports. So server RPC, 8300 on TCP. Surf LAN, 8301 TCP and UDP. Surf WAN, 8302 TCP and UDP. So this guy, server RPC is general traffic. LAN and WAN is Consul server trying to communicate as a cluster. API is the API, and then DNS interface if you're doing the service mesh and registering actual addresses for your applications. Again, some of this stuff leveraged under the hood by Vault. I know some of it, I don't know all of it, so if you guys have questions, feel free to ask. I may or may not know the answer for specifically which of these services are leveraged under the hood, because it's a little bit of magic, honestly. They really abstract a lot of it away from you. All right, and then last thing, some useful automation tips. So the backend configs through Vault CLI are brittle. All of your interactions with Vault generally are driven, at least as an end user, through the Vault CLI. That's how you do your reads. It's how you add new users. That's how you set up new backends. You set up new authentication methods. And when I say they're brittle, what I mean is If a backend config or an authentication method is already configured and you go to configure it again, Vault really doesn't like that, and it throws an error. So when you're going to automate this stuff, you can't necessarily just converge on a known state if those things are already enabled. You need to be prepared for that. There's this really cool Ansible, yeah.
Sorry, so I assume that's where when you run like Terraform apply, you're gonna have to work around that kind of situation if you're integrating with something that's like a declared state.
Yeah, so like I'm doing Ansible provisioning. And so when I do my actual configuration at the end of standing up the Vault box, if I run that last configuration again that enables the backends and the auths, it actually fails because we get non-zero exit codes on the backends. Everything else, it's fine. If you're doing writes into the system and stuff like that, it just overwrites. But for the actual enabling of built-in functionality for the backends and one of my coworkers, sitting right there, just found this really, really cool Ansible module that abstracts away some of the Vault CLI interaction. We use mainly Ansible at Sonic, so it's where my demo is coming from, and this is something that we just kind of discovered. And so it abstracts away some of that stuff. When I show you the Ansible, you'll see like it's kind of gross because I'm doing Vault CLI writes on the box. This can help clean some of that up just a little bit. Auto unseal is your friend, especially if you're running a huge cluster. The last thing you want is for a bunch of your instances to go down, a bunch of them to come up sealed, and then suddenly like half your apps are not getting their secrets properly or having to try multiple times, and you've got degraded service or an outage and you have no idea why. It's not fun. Leverage the high availability backends. Even if you're not going to immediately shift into that, secrets are important. Keeping them centralized is important. Having them highly available is important. I have played around with the non-high available backends. They work well. You know, if you back to like, I'm trying to remember, I think it was like Dynamo is what I had played with, and it works well for serving up secrets. But when it comes to like trying to expand that out and have Vault operate as a highly available backend or highly available cluster, it's just not going to be easy. You're taking on a lot of the work that's done for you if you just leverage one of those backends. And Consul KV snapshotting is magical. This is an enterprise thing, but it is straight up magical. So the idea is, again, all your stuff's stored in the back end, right? You lose a Vault box, whatever, no problem. You stand that back up, you unseal it, it's going against Consul again, everything's there. You lose your Consul cluster, you lose all your secrets. You lose all your policies. You lose all of your configuration. That's where the KV snapshotting comes into play. If you're taking regular snapshots and you lose your Consul cluster, you can stand that sucker right back up, no problem. Everything's right back. Stand your Vault instances back up. Everything's back to the way it was. But it's enterprise. So again, if you're gonna run highly available, it's something you might want to think about.
Is there any kind of manual snapshotting available to do?
Okay, so the question was, is there any sort of manual snapshotting? Yes and no. I have been tempted to try doing like EDS volume detaching and reattaching, but I have not dug far enough into how Consul actually handles its KV store to know whether or not that would work, because I'm not sure if it's in memory or not. Doesn't work. All right, we got an answer.
So you definitely want to pay for that.
Yeah.
If you're going to use Consul,
There are other backends, I don't know them, but there are a couple others, I believe, that do support high availability. I'm going to default to say if you're going to use a HashiCorp product, use the other one that works really well with it. I mean, these tools are meant to plug and play. You absolutely can use Vault with whatever you want. Go wild. And it will work well. That's the intent behind these products. But you get a lot out of using some of the other tools that HashiCorp has planned for you to use that they also happen to sell license for. So, trade-offs. Yeah, all right. It's demo time. So, fingers crossed. We'll see if this works. Real quick, I'm going to kick off some Terraform, and then we're going to step through the Terraform code so I can show you what basically the infrastructure is going to look like for a highly available cluster. I did not blow out the instances like crazy. I'm only running 3 servers and 3 Vault instances, so it's not the best. Leadership election would not work well if we lost a Consul server or something like that, but it's an okay example. So Let's do this. And I'm going to make all of the code is already publicly accessible on my GitHub. I will share those links probably on the DevOps channel after the fact. So
You had at some point you wanted to not share your screen. I'm reminding you of that now.
not yet.
Okay.
Thank you. Ansible. Ansible. All right. So for a bare bones cluster, it's 55 resources. And I'll show you why in a second. Hey man, it's expensive to run a resilient cluster. Is this going to zoom for me? Not really. Wow. That is great. Okay, hang on. Yeah. Let's collapse all and then see. Ah, way better. Okay. So here's everything. I have tried to kind of segregate the Terraform by responsibility. And then within that, I actually have the individual services I'm running. So like within Vault, there's an ec2.tf, and that's what's going to be responsible for standing up the EC2 boxes.
Multiple state files, or are you doing all the
Single state file. Question was, am I running multiple? No, single state file, and I'm using module outputs to enforce dependency down the chain, which I'll go over as well. So if we'll start with the VPC. It's a VPC, very simple. Grab me my AZs, stand up a VPC, output that ID. Public subnet, so I'm actually running 3 public subnets and then 3 private subnets, and it's because I'm not very good at routing. So this is what I had to do. I swear, I know I can route from a single public subnet to 3 privates. It was not a pretty night, so this is what I did. So just standing up all the things that are necessary, route table associations, the NATs, the elastic IP allocations, and then same with the private subnet. Private subnet, my route table associations, running 3. And so what this is going to look like is I'm going to have 3 public subnets. One of them is going to have a bastion in it to tunnel through. And then the other 2 are going to be empty. And then 3 private subnets, and each one of those is going to have a Consul server in it and a Vault server in it. So each private subnet will have 2 instances.
What are you using to route traffic?
Question is, what am I using to route traffic? Just a load balancer for Vault. Consul doesn't need any sort of that communication since it does agent to server. The Vault box will talk to the agent that's on the Vault box, and the agent will be responsible for getting traffic out to the distributed cluster however it sees fit. It's aware of all members in the cluster, so it just kind of picks one and ships it off, and that's how it works. All right. Security groups. So just to go through these because security groups are really important. The first time I stood up a Consul cluster, I lost almost a week to not having a UDP outbound because so many ports are required. So if you don't have UDP outbound configured on your Consul servers, you're going to have a really bad time. So I've got a TCP and UDP outbound all. I've got a TCP outbound all, and that's used for like the load balancer. A UDP outbound all that's used further up, and then SSH, a bastion remote login, and the Consul cluster inbound. So this is the one that is all the ports. It's all the magical ports. Now, the Vault boxes need this too because they're running a Consul agent. So this is another important thing to keep in mind because technically the Vault boxes are running Consul. They need all the same ports opened up so that it can communicate with the cluster appropriately. So 8300 to 8302 on TCP, 8301 to 8302 UDP, and then my 85 and 8600s for TCP and UDP respectively. And then more cool stuff, ELB inbound, translating that traffic to Vault. And the last one, this is required for request forwarding. I lost like 45 minutes to this last night. It's really frustrating. Request forwarding from Vault. So traffic hits the load balancer. Load balancer round robins that traffic to Vault. If it hits a Vault instance that is not the leader, it does that RPC request forwarding, and it needs to go to 8201. Vault UI, Vault CLI, all interacts with port 8200, but the request forwarding goes to 8201. It hits the Vault API as opposed to your general purpose traffic. So don't forget that, because otherwise you're going to see really weird behavior when you like try to log into Vault and stuff like that, because occasionally like you'll submit your login credentials and it will go to one that is not live and cannot successfully forward that traffic to the live one, and it just hangs. It's really annoying. All right, so Bastion, it's an EC2 instance we tunnel through. It's nothing fancy. I'm going to kind of just skip over that one for now. Consul. So this is where the magic starts to happen. We're spinning up 3 Consul servers here. We have provision keys, and we have an instance profile. Provision keys are default. That's setting up your SSH keys. Now you need an instance profile. And the reason for that is the way that I'm running this Consul cluster, it actually performs lookups against the AWS EC2 service for appropriately tagged instances and auto joins to them. So rather than having to specify specific IPs, I'm saying, no, go find your friends. They're going to have names. And I tell it what name to look for. And I'll show you that in the Ansible. So that instance profile just allows a describe instances against the EC2 service. That's it. Oh, yeah. I did inline. I don't necessarily like inline, but you do what you got to do. So Vault, kind of the same deal, slightly more complicated since we've got a load balancer, but we've got an EC2. This also has an instance profile, and if you'll look, the name is a little bit different. Again, we need the EC2 describe because we're running Consul agents on the Vault server, and they need to be able to find their friends on the Consul server and join up and start talking. So it needs to be able to describe instances. But we also need to be able to enact all behaviors, or there's probably a smaller subset, but I did all the behaviors against KMS. And this is what allows for the auto unseal. So when a Vault box comes up, it leverages the instance profile to reach out to KMS and go, hey, you got a key for me? Can I unseal? And then it unseals itself. So that one, it's roughly the same, EC2 describe, but then just allow everything against KMS from those boxes. And then load balancer. It's a pretty regular load balancer. I don't know what else to say about it. You got a listener, listens on 443, translates the traffic to 8200. It's attached to all 3 of the public subnets. And then I've got a CNAME record for it so that we can go look at it. And almost to the end here, I think. Yeah, KMS and DNS. Okay, this is easy. So KMS, easiest one of them all. Literally all I'm doing is I'm standing up a KMS key. I'll have to go grab, what's that? So KMS key is, like, I don't even know the best way to describe it. It's just a key that you can access. It's got an ARN that you can read from, and way I commonly use it is as an encryption key. So you're gonna need to have permissions to go pull for that KMS key, and then you can use it to encrypt values or decrypt them, or there's other things you can do with it, but it's basically a very secure way of storing a key to get into something. All right, and then the last one, DNS. So DNS, all I'm doing is doing automated cert validation via DNS. So this was really cool. I was really happy to find this on Terraform because I think that getting emails to validate your certs is old school. I don't think it's super new because it's an AWS feature, but I don't know how new it is to Terraform. So you basically, because this is something you can do in the AWS Console, is you can set up DNS validation. You just have to stand up your validation record in your hosted zone. But with this, you can actually set that up, and then this right here is where the magic happens. This is purely for Terraform. This does not correspond to any resource on AWS. This is for your Terraform TF state to say, yes, this cert has been approved, it's valid, so you can attach it to whatever you want. Yeah, it's really cool. But yeah, so you just have to set up the cert itself and then the validation record and then couple them together. And if you set it up through the console and you set up your validation record, it will actually automatically validate. So, again, this is just that little bit of extra something to make it work well with Terraform. I think, yeah, that's everything. That apply should be done. Nope. Uh-oh, one of them's not happy. Let's go look and see what's going on. I'll zoom in a second here, I promise. Why are these two still pending? What's going on? Well, that's obnoxious. I have lost patience. I don't even know what to do about this. Can I terminate these? No? Ha ha ha. Cool. I'm gonna kill him. With fire. All right, so terminated with extreme prejudice. We're gonna try that apply one more time. Thanks, man. 4 to add load balancer, servers. Yeah, okay, that makes sense. We'll zoom in a little more. Make sure it's really nice and visible. Actually, that's too much. Too much. Okay. So while we give that a hot second to attempt to work, let's just make sure that it is trying to stand up 2 more. All right, guys, work for me this time. Okay, so we can start stepping through the Ansible a little bit. New window. Oh, nice, it's already zoomed in for me too. This is great. Okay, I'm really sorry about the highlighting. It doesn't work super well, and I don't know why, because I've really screwed up my VS Code. But hopefully it's still readable. So console server. So this is gonna be the first playbook we run. For those of you that don't know how Ansible works, you get a playbook. Playbook has associated roles. So the roles are your kind of like chunks of work. You can reuse those as you see fit, but the playbook's kind of like your orchestrator at that point for what you're gonna enact. I'm passing 2 values in to my roles intentionally. I'll go over why those are there and what's important about them, but basically it's gonna execute against anything that's tagged this way, so we can go and look. Let's see. The other one stand up? Oh, this is not good. Okay, Demo God's not working with me today. So I'm looking for, what was it? Console server? Yeah, console server true. So I'm looking for this tag when I build my SSH config. And Ansible will then go and look for that associated tag when it goes to SSH to those boxes and execute. I wonder why this is. All right. So if we go look at this, and we look at console, so we're running the console role, and we'll start with tasks. Tasks are going to be the things that you're executing, right? So first thing that I do is I go and I download the console executable. I generate a group and a user to run it under. Unzip the executable off to user local bin so it's accessible, and create the configuration directories, so console and console.d for logs and for the actual console config itself. And then I copy over the config. If we go and look at that config, this is part of, these are the 2 values that I'm passing on that playbook. So one of them is determining whether or not I'm standing up servers or agents. And the other one is for the bootstrap expect. So the bootstrap expect is basically telling the console cluster how many servers to expect when you're instantiating. It was just real finicky with me. Ideally, I would have liked to remove it, but I had to include it. And even though bootstrap is false, it still needs to be there on the like instantiation if you're doing a bunch of clusters at once or a bunch of console servers at once, just so that it knows what's going on. So I'm telling it, expect 3. And then, yeah, and then the server is server, and then this is the other part. So this is why we needed that instance profile. I'm basically declaring in this retry join, hey, go to AWS, look for this tag, and look for the associated value of that tag. If that's one of those instances, join to it, become a cluster. And then copy over some configs. Nope, that's not right. So the console.service config. So I'm running this with systemctl, which is one of the recommended ways to run Consul. Same with Vault. But the console.service just looks like this. We got an exec start that goes and hits the console executable for agent, specifies a config dir, and you're good to go. And then, yeah, starts the agent up. So in an ideal world, if my instances would stand up, we would be in a much better place. Okay, I'm gonna fix this. Kill it all. Yeah, you guys will see my shame soon. I've got like probably 20 plus KMS keys queued for deletion from all the times I ran Terraform destroy last night and then recreated. It's a little horrific because they want. Okay, it's a 7-day deletion window. Are you kidding me? Let me set it to 30 minutes. Like I know what I'm doing. I promise. I promise you, I would not be doing that if I didn't really want to. Huh. Yeah, something got real weird there. Okay. Well, we let that destroy. Yeah, well, I guess we'll go through the agent one too. Okay, so the next step would be to stand up your console agents. So you need to have your server stood up so you have your cluster, then you get your agents stood up and talking to the cluster, and then you would step into actually configuring the vaults to talk to the agents. If you go out of order, Vault's gonna be really mad because it's not gonna know who to talk to, or the console agents are gonna join as a cluster of entirely agents and you're gonna be missing servers. It's just a better flow to go this way. So look for tag console agent true. So on the EC2 instances, I have a tag console agent. The value associated is true. I'm executing that console role again, but this time I'm saying it is not a server, and I'm saying bootstrap expect fault or 0. The reason for that is an agent does not care how many instances are in a server and will actually throw errors at you if you include a value greater than 0 in bootstrap expect. It's just, it gets real angry with you. It's like, I don't care about how many things you have in your server. I'll figure that out once I connect. So it does all the same things, sets up the systemd, copies down console, but this time it's doing it onto the instances where the Vault servers will be running. And then we'll have that communication. Oof. This just takes a hot minute. Okay. Then we've got Vault. So Vault goes, and I got tricky with the tagging, more tricky or lazy, depending on your definition. And I was not super verbose with it, so I just said, hey, anything that's running a console agent, anything that's tagged console agent true, well, I know that's gonna be a Vault box, so that's where I'll execute it. And let's go to here. So what I do with Vault, super simple, downloads the executable, creates the group and user, makes sure that that executable is accessible in user local bin, sets up the configuration directories, copies over the Vault config, which this is one of the things I have to replace if I get this to stand up. So you have to specify the KMS key that it's gonna reach out to auto unseal. And again, this is what that instance profile is for as well, to allow you to look for that ARN and say, hey, I can find it, I can reach it, I can use it to unseal myself, so I'm gonna do that. I'm specifying a console storage. Now you can also do an HA storage that's separate. Console by default gives you HA. So there's a storage stanza that you see here, and then there's another one that would be something like this. That's I think what it is. And then you would specify an address and a path. So because console comes with that stuff rolled in, I don't have to do that. It automatically does that, and I'm telling it to talk to the console agent that's located on the same box. I'm hitting localhost, and I'm giving it a path. So I'm saying, hey, when you go and communicate with the storage backend, the place I want you to put your configs is in /vault. Because remember, Vault operates like a file system. So console is providing that backend, it's providing the KV store, but the path to it, I'm gonna say Vault is gonna be the key that all of your configurations are stored under. Oof. Something's real angry with me. And I bet you it's because of this one. Anybody know if US East 1B is having trouble? Let's find out. Let's make sure. Yeah, US East 1B. Okay, we'll let that finish shutting down since it's trying to. Okay, and then the last one. This is where I start to get into a little more of the actual configuration of a Vault instance once it's up, right? So if we look at playbooks, configure backends. So I'm doing a few things here. These are not good practices. I strongly recommend against them, but for the sake of time, this is what I had to do. So I am going to be setting a Vault token. This will be the root token. So when a Vault comes up and you initialize it, you get 5 access keys by default that you would normally use to unseal unless you're using an auto unseal functionality. And then you get the root token. The root token is exactly what it sounds like. Honestly, you should throw away the root token when you get it so long as you have your keys, because you can always generate a new one, and you don't want anybody getting access to root unless, you know, I mean, maybe you want it, so I could understand that. I definitely wanted it. But in general, throw that away. Don't keep it. And I think you can actually invalidate it after you unseal as well, but I can't remember for sure on that. So I'm going to pass those things in, and then I'm also passing in an IAM access key and secret access key. So I've configured by hand, this is not a part of the Terraform, another IAM user that's just an admin on my AWS account. And I'm going to use that access key and secret access key to basically lease IAM roles, time-based IAM roles from AWS to do like EC2 reads, I think what I have the policy permissions set to. So looks a little something like this. So first thing I do is I log into Vault with that Vault token. It's bad, don't do that. Make yourself an account. Only, or actually really only use the root token to generate a admin account that is not root. Then I enable the user pass, so this allows you to use username password login as opposed to token-based login. So this is for your end user, right? This is, you've stood up your Vault cluster and you know, you've got 3 different development teams that all need their own space and the ability to log in. User pass is your best friend. Then I enable AWS. This is where the magic happens for the credential leasing. This is that backend, right? So the next thing that I do with that is I write that access key and that secret key as well as the region into AWS config root. Then I configure the IAM role. So basically I say, here are the IAM roles that you are allowed to lease for this role I'm setting up on Vault, and I'm associating them. So I'm saying, here's this Vault role, EC2 read. You're going to be allowed to have IAM read-only access and EC2 read-only access. Every time that you do an IAM user against AWS, you have to give IAM read-only access. That has to be one of the policies you give, because otherwise, when Vault goes to reach out, if it can't query IAM for the other roles that you might be adding, it literally can't do anything. So that has to be included. And then I do go ahead and add a Vault user just so you can see what that looks like. I'm not actually going to use it if I can make the demo work, but we're really running out of time, so maybe not. But that's the basics of adding a user, and then you would have the user that you've created, you'd have whoever it's for, go in, log in, change their password. And they can do it with a Vault write just like this. So they would do a Vault write, and then they would change what the password value is that's being passed in. And that's that. Okay. Did this, nope, I don't want you. Looks like that terminated. Let's make sure everything else is dead. Nope. Yeah, man. I'm so annoyed. I had this all set. It was going to stand up. It was going to be beautiful. It was going to work flawlessly. No, not today. What? Well, it was charging me. I'm up to like 15, 16 bucks on my AWS account, man. I don't know, 12 of that was for the domain registration, so. Yeah, I really wanted to treat everybody. So no A records on the load balancer. I purchased vaultexample.com from Amazon. I'm gonna be really sad if I don't get to show this after all that. Okay, so here's the bastion. We got zeros. We got some of the ones. What I need to do is filter out for. I'm missing a vault server. Vault 0. I'm sure it will. I don't think it created yet. 1 and 2 console servers. There it goes. Yeah, it's kicking off. Come on, guys. So who was it? One was the problematic one. That's what it was. And zeros and twos are okay. Ones are taking a while. That fills me with a great sadness. I could skip 1B actually. Oh, we're doing it live. Okay, hang on. We're doing it live. Get ready, folks. You're in for a ride. I'm telling you, this works. I can make it work. I swear. All right. This is why parameterizing is really important, because I can just do this. And that actually should solve literally everything if this is what's going on. Yeah. No, those things are just. I think it's yeah, something's not working quite right. So, huh? I mean, let's be real. Who knows? Okay, we're just gonna kill that. Yeah. Why? Okay, yeah, I see what you're saying. Don't do that. Do this. It'll save me time. You're right. Running out of time though. All right, recreating a whole bunch of things. That's fine. Oh, if these come up, I'm gonna be so happy. Come on. Come on, guys, you can do it. Yeah, everything. I did last time. Yeah, the GoCD one worked flawlessly last time. No, it was something. Oh, it's going to be stuck on one. I might have to run a Terraform destroy. Yeah, we're probably going to run out of time. Okay, well, while this destroy runs, so these are public repos. You can pull them down. The only thing I haven't put in the Terraform is the TF-vars. And then in the Ansible, you're going to have to build your tunneling configs by hand. It's the only other thing. But magic. Yeah, and here I'll show you an example of, that's something I didn't go over actually. So the way that Ansible works is it actually leverages this inventory. So EC2Pi, public and private are really important. This is what allows you to query your AWS service if you pass AWS creds to it. So it allows you to query your account for the associated tags. And it looks for this tag for what you're trying to fully connect to, the Bastion host, and then the keys. And I did different keys for each one. So you'll see that in the Terraform. I have a key for the VPC and the Bastion instance. Yeah, just different, what are they called? Key something. But yeah, and then provision keys, there, it's right in front of me. So I did one for the Vault VPC, I did one for the Vault boxes themselves, and one for the Consul boxes themselves, because this is about security, right? So we need to be as secure as possible and have as many keys as people need to have to get into these boxes. So that's how that works, and then you would need a tunneling config, and the command, I actually included the commands in here too to make it nice and easy. If you build out your dynamic Ansible config file, you just specify the path to the private.ini, the AWS profile you're querying with, so you need to have your credentials set up on your box, and then the ec2.py, and this is basically what tells it, hey, query. Private gives it the permissions to query for private instances, but ec2.py is what I think really facilitates the communication to AWS. So every single one of these should be executed like that once you have your Ansible config set up. Otherwise, you're going to get weird errors like couldn't connect to the box or key invalid or whatever else. Yeah. And then I also included, if you do set up the EC2 read AWS IAM stuff, that's how you would read that credential out, and what it will spit out to you is an access key ID and a secret access key that is, I think I have in the Vault configs, I have it set for least credentials to expire after 15 minutes. So it is valid to do as many EC2 reads as your heart desires for 15 minutes. And then you'd have to lease it again. So I guess the demo's not gonna happen. Anybody have any questions? I guess I could answer questions and try to really stretch this out a little longer to see if I can get the demo going. Questions? No? Wow.
What are the real pain points?
Other pain points? The real pain points are mainly, so it's, I would say, automation and then process once you have this thing stood up, right? So if you're going highly available, I mean, it needs to be really robust to make sure that you're not coming up sealed, to make sure that all your stuff's accessible, and then also make sure that like your app roles are still configured when it comes up so that your secrets can be retrieved by your applications. The other pain point I would say is more the human process. That's something that I'm still trying to wrap my head around of, okay, so you've stood up your Vault cluster. How much of the actual configuration and maintenance of this can be automated, or how much of this needs to be eaten as an ops cost, and you have an ops team that's responsible for maintaining your groups, maintaining your policies, making sure users can get access. If a Vault seals, do you blow it away and recreate it? Do you go figure out why? Like it's more the balancing of where the automation stops. The other thing that was a pain point up until recently, because I was way overthinking it, was there are some like Vault level configurations that are secrets themselves, and so you need somewhere to store them. But that can be easily solved with like an encrypted repository or something like that, because it's only a few values. Yeah, this isn't happening. Is it an instance that's? No, it was trying to kill public 0.2 and the internet gateway. Yeah. I mean, I can leave those up. They're not going to charge me for those. I can destroy them later. Let's see, VPC. You guys are getting a tour of my AWS account. Enjoy it. Oh, it's multiple publics. Gross. Oh, did you? Yes, I do have MFA. Network interfaces. So, what, route tables, amongst other things? No. Let's kill the gnats first, I guess. Nope. Thanks, Amazon. You're the best. How many things are left to destroy? EIPs, an internet gateway, a couple subnets of the VPC. I can do that. Huh? Oh. That would do it. Okay, we'll kill the internet gateway next, I guess. I can only detach it. It's not what I want. Let's just try to destroy one more time. Oh, it's working. Sorry. Oh, please do. Go ahead.
One cool thing that Tyler kind of alluded to earlier was the auto unseal stuff. That was all enterprise up until November last year. So as Hatchie continues to evolve this stuff, they are rolling stuff that was an enterprise down in community as well. The community's been asking for it. So even if it's an enterprise right now, it's not going to always be an enterprise. So continually looking at how to deal with all of their products that they do and everything. So one cool thing about Vault is it just became one dot last year.
They're valued at like, what was it, 8 billion?
It's for the big companies that need to use this stuff, but really the reason people go for enterprise is for the support of it and then DR, because a lot of the community editions don't come with the DR portion of it. So like bigger companies that need to have a DR but don't invest the time and resources into it will go for enterprise because they need the support for it. If something breaks, and then the DR can go. That's mainly what you get with enterprise versus commercial.
I've never seen a company that system that puts out so many good open source products.
Like amazing ones like that. There's an enterprise version of Terraform. I don't know why anyone would ever use that. Why would you use that?
Oh, it's totally working. The one that, yes! 1D for the win. Okay, they're all running. Okay, we're gonna rapid fire this. Get ready, folks. Actually, I'm gonna just. So I got a handy dandy little script here to build my configs for me. Now let's just do this. Playbooks. I'll grab this one. That is not the right one, but that's okay. Consul server.yaml. Perfect. Okay, so I went ahead and built a dynamic Ansible config. This is basically going to own my SSH tunneling configurations to the, I picked the Consul servers, so we're going to stand up the Consul servers first. And this should work even though they're still initializing. If it doesn't, then yep, cool, it's working. And then we'll get on the box and I'll show you kind of the best way, a couple of quick ways to make sure that everything is joining correctly and the cluster's building. Almost there. All right, so now if we get on one of these boxes, so we know that the console tool is here, and we're gonna do first a members. So this will list all the members in the cluster. And if you look, we've got 3. So those 3 agents got console installed, use the retry join configuration piece to reach out to AWS and say, find me my friends, and connected with them. And if you do the monitor command, it'll let you look at the logs. So it shows, you know, discovering the LAN, the event member joining, it's syncing, and then actually doing the election for leadership. So that's one. And then now we're going to do the agents next, and then we'll do Vault after that. And I'm just not going to worry about the backend config. That was icing on the cake. I'm not going to risk it. So next up, we're running the agents. So this is going to go out to the Vault servers themselves. So we've got console servers, which is what we just configured. It's our server cluster. And then we've got the Vault servers. So this is going to run against those and stand the agent up on those ones. Almost there. Go grab one of these. So again, putting that console executable in the same place, so we can do this. And now we have 3 servers and we have 3 clients. And then if we monitor, the important thing to note is the agents are not very chatty. So this is going to be the extent of it. When you have interactions with the servers will log them in the console monitor. Agents don't really, because the agents are just there to facilitate requests. So they're really not tracking everything else that's going on. So if we were to come back in 10 minutes and hit console monitor again, all of this would have fallen off. You could still go find it in the log, but monitor is just going to spit out recent activity. Okay, and now since I did that fancy magic with the tagging, I don't even have to establish new Ansible configs, and I can just go stand my Vault boxes up. So this is going out to those Vault servers that we just configured the agents on, and it's going to set up Vault. And then if we watch here, this should stand up in a second. I'm copying too many files over. Maybe I should create them on the fly. I wonder if that'd be faster. I don't know, man. Like, this is slow. And I had plans to be going over code while these were running, so. Yeah. Nope. Wait for it. Oh, the load balancer's not registering them yet. I have it set to 10-second health checks, so there it is. We now have Vault. We have one more step, and that's to initialize. And so I'm going to do this and this because I want this to be really visible. So right now, this isn't initialized yet. But what I want to do is, if you look, I think this will do it. I've already set my Vault address in my mvars. So Vault CLI will look for that, or you can specify it as a part of the command. But since I've already set it, I can do this. Oh, I forgot to update the KMS key. Had I updated the KMS key, this would have automatically unsealed. I would have gotten my five keys and the root token. But I did not update that ARM. And to show you how many times I've forgotten that, because that was the main problem yesterday, these are all my keys. And there's the second page. So, 7, that you can go up to 30. And I get why that's there, but again, AWS, trust me, man. If I'm doing that, I'm doing it for a reason. There's a reason I'm killing it in 30 minutes. But yeah, that's pretty much everything. And yeah, I'll throw these links up on DevOps so you guys can go take a look, clone them down, take advantage of them, stand them up, play around. The logic's pretty much the same. You can use another tool. You don't have to, don't feel required to use Ansible by any means. The flow is still the same. You just might have to figure out how to make that happen. Yeah.